Hey, 7th grade. This video is going to start our next unit of study, and this next unit we're going to talk about inequalities and how to solve inequalities. You're going to find that inequalities are very similar to equations, so if you're comfortable solving equations like we did in our last unit, hopefully this next unit won't be too bad for you because it's going to be very similar to the stuff we did in the last unit. The one thing that we're going to add, though, in this unit is we're going to learn how to graph inequalities. And so that's what the majority of today's video is going to be, how to graph inequalities using a number line, which I believe will be a review for you from 6th grade. But if it's not, I'll try to go kind of slow so you can pick up on this. So first of all, let's talk about what an inequality is. Okay, an equation, you know from the last unit hopefully, is basically a mathematical sentence that uses an equal sign to state that two different expressions are equal to each other. An inequality is very similar to an equation, except an inequality states that two expressions are not necessarily equal to each other. Okay, so one expression might be larger than another expression, or one expression might be smaller than another expression. A solution of an inequality is going to be any number that makes the inequality true. So when we solve inequalities, that's another way of saying find the solution. It's just to solve the inequality. Unlike most equations, though, inequalities often have many solutions. Okay, so let's go ahead and let's look down here at example 1. For each of these parts A, B, and C, we're going to determine whether each number is a solution of this inequality right here. 2x plus 1 is greater than negative 3 is how we say that. And we'll review the inequality signs here at the bottom of the notes. 2x plus 1 is greater than negative 3. So to find whether negative 3 is a solution of this inequality, we're just going to substitute a negative 3 in for x. So we're going to do the following. We're going to take our inequality 2, and instead of x, we're going to put in our number negative 3. So 2 times negative 3 plus 1 greater than negative 3, and we're just going to see if we get a true or a false statement here. 2 times negative 3 is negative 6, plus 1, negative 6 plus 1 is negative 5, so we get the statement negative 5 is greater than negative 3. Negative 5 is greater than negative 3 is a false statement, because negative 5 is actually less than negative 3. So this right here, negative 3, is not a solution of that inequality, so we would say a no for that one right there. Now let's try negative 1. We're going to do the same thing here. Take our inequality and substitute a negative 1 in for the x and see if we get a true statement. So this is 2 times negative 1 plus 1. That would give us negative 2 plus 1 on the left side. And so then we get negative 1 is greater than negative 3. Negative 1 is in fact greater than negative 3. So that means that negative 1 is a solution of this inequality. So that's a yes. And then 5, if I plug in a 5 to my inequality, we get 2 times 5 plus 1, which is going to be 10 plus 1 greater than 3, so you get greater than negative 3. So you get 11 is greater than negative 3, which is also true. So 5 is also a solution to this inequality. So if you're ever given a multiple choice problem and I ask you which of the following is a solution of the inequality, one way you could do that is just like with equations, plug each of them in and then see whether or not you get a true statement. Now let's talk a little bit more about your different inequality symbols. So we're going to talk about how to graph today. Okay, how to graph inequalities. We graph inequalities using a number line. And there are two different parts to the graph of an inequality. There is what we call the dot, and there is what we call the shading. Okay, so let's talk about your inequality symbols first of all, though. There are 4 inequality symbols. You're going to see this symbol, which we talked about in example 1. This means greater than. And then sort of the opposite of this symbol, it's with the arrow pointing the other way, that is a less than symbol. Okay, so if you saw something, an inequality like this, that would be read as x is less than 5, meaning x is a number that's smaller than 5. If you see this symbol right here, this is a greater than with a bar underneath it. That means greater than or equal to. So if you saw an inequality that looked like this right here, we also have a less than or equal to symbol. This would mean that x is a number that's less than 5 or equal to 5. So x could be 5 itself, because 5 is equal to 5, or x could be any number that's smaller than 5, 4 or 3 or 2 or 1, etc. So again, that's a less than or equal to sign. Okay, so when we're graphing, it's really important to pay attention to what the sign is, because that's going to tell us two things about our graph. Okay, it's going to tell us what type of dot we use, and you're going to see what I mean by type of dot when we go to the backside and do the examples there. You're also going to look at the inequality symbol to figure out which way you shade on the number line. So let's start with the type of dot. Anytime you see a greater than or a less than sign, you're always going to use what we call an open dot, or sometimes we call it a hollow dot. An open dot or a hollow dot, sometimes we'll call it an open or a hollow circle. So greater than or less than, we'll always use an open dot. A greater than or equal to, or a less than or equal to, we will always use a closed dot or a closed circle. Okay, the way you tell is if you have the little equal to bar underneath your inequality, that's when you're going to use a closed dot. If you don't have that equal to bar, that's when it's going to be an open dot. The shading, so when we graph inequalities, we also shade if you have a greater than or equal to sign. So if it's any kind of a greater than, you're always going to shade to the right. If you have a less than or equal to, you're always going to shade to the left. Now I should put a disclaimer when I say you're always going to shade, and that's down here where it says important. Okay? When I talk about you're always going to shade left and always shade right, you only do that if the variable is on the left side of the inequality. And you're going to see again what I mean when we get to a few examples. So these rules are assuming that the variable is on the left side of your inequality. So now let's go to those examples 2 through 5 and see what I mean by this. So for each of these, we're just going to practice graphing these inequalities. And so for each of these problems, we need to draw a number line first of all. Okay, and your number lines don't have to be anything fancy here. You're just going to draw a nice line with at least 3 tick marks on it. So we're comparing x to -4 here. So I'm going to put -4 right in the center. And then I'm just going to go one greater than -4, which would be the number -3, and then one less than -4 would be -5. So we're talking about x compared to -4. So everything that we shade and that we put a dot on for the graph is referring to x. Okay? So the first thing I'm going to do on my number line is I'm going to put my dot. This is saying that x is greater than -4, but not necessarily equal to, because there's not that bar underneath. So I'm going to put a dot on -4, but I'm going to put an open dot on -4. And what that tells me is that I'm not including -4 when I put my dot here. Okay, I'm not including -4, so that's why I'm leaving it as an open dot. The next thing I'm going to do is I'm going to shade my inequality. I can shade two directions. I can shade either left or I can shade right. We're talking about all the numbers x that are greater than -4. All of the numbers greater than -4 would be -3, -2, -1, all the numbers to the right of -4 if you're on a number line. So that's why I say when the variable's on the left side here and you have a greater than sign, you always shade right. These are all the numbers that are greater than -4. So x could be any number that lies in this green region. Okay, it could be -3, it could be -2, it could be way over here on the right at 25. Any number that's greater than -4 would work and make this a true statement. But again, we're not including -4 because we're using a hollow dot there. Let's talk about number 3 now. We have the inequality c is less than 0. So when I make my number line, I'll go ahead and I'll put 0 in the middle, and I'll go 1 to the right, and then -1 is on the left. So the first thing we think about is what kind of dot are we going to use. We're going to put a dot on 0, and this is a less than, not a less than or equal to, so we're going to use an open dot, because again, we're not including 0 in this. So an open dot on 0, and C is less than 0 means we're going to shade all the numbers that are smaller than 0. So those would be all the numbers that are to the left of 0. Basically all of our negatives. So any number that is in this shaded region here, any negative number, would be a solution. Okay, any number that's not in the shaded region, including 0, would not be. Now let's look at number 4. Number 4 says we have 3 is less than or equal to n. So I'll draw my number line for this one. We'll put 3 in the middle. 4 can go on the right, 2 can go on the left. First thing I'm going to do is put my dot down. This is a less than or equal to, so that means we're including 3 in the mix here. And so I'm going to go ahead and put a solid dot on 3. And here's where you have to be careful. This inequality is saying that 3 is less than or equal to n. It's not saying that n is less than or equal to 3. So what I would do before I graph this is I would reverse this and write it so that the variable comes first. If we put our variable first and we put n on the left side, 3 is less than or equal to n means the same thing as n is greater than or equal to 3. Okay, think about that for a second. If 3 is smaller than n has to be larger than 3. So you might have learned about the crocodile in 5th or 6th grade when you talked about inequalities. If the crocodile is eating the variable, when you rewrite it, the crocodile still has to be eating the variable. So now this is going to be a greater than or equal to sign if I switch it around and put my variable first. So if n is greater than or equal to 3, that means we're going to shade everything to the right of 3. So when you're doing your inequality graphs, you have to think about the variable coming first and then base your shading on that sign there. Okay, and then number 5, we have x is less than or equal to negative 5 halves. So negative 5 halves, we should be able to know find the decimal equivalent of negative 5 over 2. If you just do some dividing, negative 5 over 2 is the same thing as negative 2.5. So we could say also x is less than or equal to negative 2.5. So in the middle here, I could put either negative 2 or negative 3, or even negative 1 if I wanted to. I'll go ahead and put a negative 2 there in the middle. Negative 1 would go to the right, negative 3 would go to the left, and now I'm just going to put my dot where negative 2.5 would approximately be. That would be halfway between negative 2 and negative 3, and we're going to use a solid dot because this is a less than or equal to, so we're including negative 2.5 here. It's x is less than or equal to negative 2.5, so that means I'm going to shade to the left of negative 2.5, and so that would be what my graph looks like for this one. Okay, for 6 and 7, we're just going to do the opposite of what we did in the previous examples. So for these, I've given you a number line, and you're going to write me the inequality that represents the graph. So for number 6, we can see that we have a dot on 1, and we're shaded to the left. And so that means I'm going to use a less than sign in my inequality, because I'm shading all numbers that are less than 1. So we can go ahead and we can pick our favorite variable. I'm just going to use an x for mine, and I can say that x is less than 1. Now, if my dot is hollow, then I'm done, because for hollow dots, remember, I don't need the bar underneath my inequality sign. Because this is a hollow or open dot, that means that this here is actually my inequality, just all numbers that are less than 1. For number 7, this time I have a dot on negative 2, and we're shaded to the right. So that means that all numbers that are greater than negative 2 are shaded. So I might say something like m is greater than negative 2. I have a solid dot though for this one, so because this is a solid dot, I need the equal to bar underneath. So this one would be m is greater than or equal to negative 2. If you had any questions for this video, make sure you jot those down so that you can ask those the next time I see you in class. And until that time, have a nice day. You're all wonderful people. Take care.